so let's see here. Alina, what'd you get for the radius? On number 2, what's the radius on number 2? It's not a pretty whole number, that's for sure. Alina, are you there, honey? And
I don't exactly know how to find the radius.
okay. So let's do what we got like in purple up here to find the radius. So I'm gonna reach out to, let's see, who was I talking to? So Kaylee, you set yours up, right? How'd you set it up for the radius? Uh-huh. All under square root. Okay, so you took this XY point and so we were using what was up over here? Yeah. All right, so Alina, do you see this formula for the radius right here?
Yeah.
Yeah, we see that? Okay, so I'm using the XY point to get the X and Y in this radius formula. It's pretty much basically like Pythagorean theorem. All right, yeah, Ryan, what'd you get? Or is that a question? So what about the radius? No, I didn't, Ryan. We're good. So we just found that the radius is a square root of 13. I actually can't even simplify that. 13 is like a prime number. That's as good as it's going to get right there. So Alina, are you okay with this so far?
Yes.
Nice. Okay, so then let's do our sine of theta. I don't even know what angle this is. I'm just doing sine of theta, cosine theta, and tangent of theta. Okay. So according to my little information up here, sine is the y over the radius r. All right, so Fiona, what'd you get for your sine? That's okay, you can see it right here. It's the y over your radius r. What's the y? -3. Okay, over, what was the radius that we just found? Square root of 13. Nice. I do have some simplifying to do. I'm not supposed to have a square root in the denominator, so let's rationalize the denominator. So I get a -3 root 13 over the whole number, 13. All right, so that's considered the simplified version for your sine of theta. All right, and then Marcus, what'd you do for cosine?
It was kind of the same thing with sine, just with x.
Okay.
But then you have to rationalize.
So with the x, what was your x on this one?
2.
2, so 2 over the root 13?
Right.
And you said rationalize. Nice. Okay, so how do I rationalize again?
Times it by root 13 over root 13.
Nice, root 13 over root 13, which gives me a 2 root 13 in the numerator. Like I have a messy numerator, but I do have no square root in the denominator. So that is simplified. All right. And then Abdi, what do I do for the tangent? Nice. 2 over -3 like this? Yeah. Super close, super close. Oh, -3 over 2. There we go. It's your y over x. But yeah, you didn't need the root 13 on this one, right? Yeah. So -3 over 2. That's my final answer for tangent. Okay. So the whole point on these is they can now ask you for any of the 6 trig functions based off of any xy point that's not, even if it's not on the unit circle, you can still find all 6 trig functions. All right. Any questions on this before I move on? All righty, let's look at this one then. You've got some information about the quadrants. We have talked about all 4 quadrants. But in my first quadrant, the theta, just remember, theta means your angle. Your angle is between 0 and pi halves in your first quadrant. If you're talking degrees, we're talking it's between 0 degrees and 90 degrees. Pi halves, radians is the same spot as your 90 degrees. Now, this also means your x is greater than 0 and your y is greater than 0, meaning that you've got a positive x and a positive y, which I think you guys already knew that about your xy points. Like if I go over here in my second quadrant, I had to go to the left. I've got like a negative x, but I've got a positive y. So your x is less than 0, your y is greater than 0. This is between pi halves, which is like 90 degrees, and pi radians, which is like 180 degrees, like half circle. Again, it's because we start at the positive x-axis, so it was like 90 degrees. Now we're at 180. So keep it going. Down here in the third quadrant, both the x and the y are negatives. So that is between pi radians, or 180 degrees, and 270 degrees, or 3 pi halves radians, same thing. All right, and then my fourth quadrant has a positive x and a negative y. So that's why the x's are greater than 0 and the y's are less than 0. And then that's going between 3 pi halves, or 270 degrees, same thing, and 2 pi, which is a full circle in radians. 360 degrees is a full circle in degrees. Okay. So basically all this last one adds is what happens with tangent. I knew that my sine and my cosine, like my x's and y's, are both negative in the third quadrant. But since tangent is sine over cosine, it's like a negative over a negative. So I end up with a positive tangent in that quadrant. This is just kind of your tangent information right here. Like positive over positive is positive. Positive over negative is negative. Negative divided by negative is positive. Negative divided by positive is negative. So really, okay, yeah, we put this purple one right here. We gave you that. But if you knew the sine and cosine stuff, you really would have found what sign you had for tangent anyway. It's kind of great that they lined it out for you, but I think you could find it anyway. All right, so let's see if we can use that for these guys. So given that your tangent of theta is a negative 5/4 and your cosine is greater than 0, you have to find sine of theta and secant of theta. Okay, where am I at on my unit circle if my tangent is a negative? First of all, let's look at this. I have 2 possibilities. So let's see, I've got, Francisco, you're online today, right? All right, so Francisco, there's 2 options where your tangent will be a negative number. Which 2 quadrants are we talking about that your tangent's negative? Two and 4. Okay, we got quadrants 2 and, ooh, what's happened here? All right, so 2 and 4. Good. And then they also said that my cosine is greater than 0. So I got a positive cosine. So out of these 2, let's look at the cosine. Cosine was negative there. Cosine was positive here. Okay, so I'm going to narrow it down. You said we had 2 quadrants, but I'm going to narrow it down to this 4th quadrant. That's my only option that makes both of them true. Both my tangent is negative and my cosine is positive there. So we've got down here, I'm gonna put a little triangle down here. Here's my angle, theta. And the tangent is a -5/4. I think my y value is negative here. My x value should be positive though. So tangent was, do you remember if tangent's y over x or x over y?
Oh, it's Y over X.
Y over x. So I'm going to treat this like a -5/4 because having a negative y value kind of makes sense in this quadrant and a positive x value also makes sense here. So I'm going to go with a -5 and a +4. Okay. If I'm going to find the rest of my trig functions, though, I do kind of need the hypotenuse. Let's do some Pythagorean theorem, get the hypotenuse. So let's do my a squared plus b squared equals c squared. All right. All right. So, okay, this is not pretty. I'm up to what, 41 for my c squared. So if I take the square root, I should have a positive and then root 41. Not very nice, but here's my hypotenuse there. Here's my c side. But as messy as that is, I can now find whatever trig functions I want. They want the sine and they want the secant. Great. Sine is your y value over the hypotenuse. All right, so let's see, my y value, we labeled this was a -5. So we'll do a -5 for my y over a root 41 for the hypotenuse, which I do need to simplify this. It's like we did on the last problem. Okay, so it looks really messy, but this actually is, oops, whole number 41 there. It's actually considered simplified. Where's my sine? Let's check out the secant. We've been finding sine, cosine, and tangent. We haven't found secant yet today.
Actually, radius is hypotenuse.
Oh, it's the which one?
It's, I believe, it's R over X.
R over X. Okay, so yeah, the radius, which we just found, the radius was a root 41. So secant of theta, to be right, radius over, what was it, over X or Y? X, which in our case, the X value is the 4. And I'm not dividing by a square root on this one, so this actually is considered simplified. There we go. As long as I find all 3 sides of my triangle, I can then find whatever trig functions they want. Okay, what kind of questions do we have on number 3 before you guys work on it on your own? What kind of questions do we have? Nothing for reals? All right, then I'm going to have you guys do number 4, very similar to number 3. Let's see if you guys got it. All right, so I'm just gonna start calling on people. We're gonna have, Kevin, I'm gonna have you start out with like the stuff I put in black, like how to put this on the graph. And then 80, I'm gonna have you pick it up from there. After we do the graph, you're pretty much gonna do the stuff in purple to find your missing side. All right, and then let's see, Kislev, I'll have you pick it up after there. You're gonna help me with my first one, which is cosine in this case. So Kislev, you'll help me find the cosine. And then Jack, you'll help me find the tangent. All right. Okay, so like I said, in black here, I'm going to put this on my graph again. So Kevin, how do I start with this graph? Okay, sine is a positive number. So you got, and your tangent is a negative number. So positive signs are like positive y values. It's got to be in either quadrant 1 or 2. Where are your negative signs again? Or sorry, negative tangents? 2 or 4. So you went with quadrant 2. That makes both of those true in quadrant 2. So we're going to draw a little triangle over here, right triangle over here. And theta is toward the origin there. All right, so can you label the 2 sides? They only give you 2 of those 3 sides. Which 2 sides am I going to label? The opposite and the hypotenuse. Okay, so the opposite tangent, or sorry, sine is opposite over hypotenuse. Opposite being the 4, hypotenuse being the 5. We go with that? Nice. Okay, so you took care of labeling. We used the information we got, labeled as much as we could. We still have to go find that missing side though. So the tangent was negative because they said tangent of theta is less than 0. So that's why we knew we had to look for where the tangent is negative, which up here we had tangent was negative in these 2 quadrants. All right, cool. So then let's pick it up from there. I'm gonna have 80, I'm gonna have you do the stuff we did in purple. You're gonna find this missing side on my triangle. So let's just walk me through this here.
All right, so since we know that our hypotenuse is 5 and that one of the sides is 4, we're just gonna use the Pythagorean theorem to find that y equals positive or negative 3. And since...
Okay, so sorry, can you walk me through how you set up the Pythagorean theorem?
Yeah, so you have a squared plus b squared equals c squared. So I just rearranged it to say c squared minus b squared equals a squared.
Nice. So you said we knew one of these guys. So which one did you subtract over, the a squared or the b squared?
The b squared.
All right. So c squared minus b squared. All right. Nice. And then you plugged your numbers in here?
Yeah. So the c is going to be 5. So 5 squared, which is 25, minus b would be 4. So 4 squared equals 16. That equals 9. And then the square root of 9 is positive or negative 3.
Nice. And which one did you go with, the positive or the negative?
I went with negative because we know that sine is positive and tan is negative. So if you find that on the little chart from above, we can also see that cosine will be negative.
That is true. Very nice. And we also have even another reason why, and that's because of where Kevin put this in the second quadrant, right? And there's got to be a negative x over here. So yeah, multiple reasons why we would have to go with, out of your plus or minus, we had to go with the negative 3 in this particular case. So yeah, you guys will have to pay attention to whether you choose a positive or a negative when you take the square root. All right, looks good. And then we're gonna have, Kislev, you're gonna pick it up from here. We are doing our first trig function that they wanted, which was cosine. So let's do cosine of theta.
Okay, so cosine is x over r. And so
Alright.
x is -3 and r was 5, so it'd be -3 over 5.
Nice. And I actually don't even have to simplify this, so done. Very good, very good. And then we've got, let's see, Jack, you are then on to the tangent of theta. So help me find the tangent of theta.
So wouldn't tangent then be putting 4 over -3 and then it comes out to -4/3, or am I mixing those sides up?
That was great. So you can, if you're looking at a triangle, you can treat it as opposite over adjacent, which was 4 over -3. Or if you looked at what we had up here, your tangent was the y over x, which is still going to be a 4 over -3. Yeah, either way, you got it, 4 over -3. That's good. Okay, so any questions on this stuff? Yeah.
Wait, so I thought the numerator was the x.
The numerator for your sine, like out of your 4/5, is that what you're talking about?
Yeah.
Okay, so your numerator for sine here, sine is y over r. So the numerator had to be the y value, which in this case, the numerator was a 4, so my y value had to be a 4. And we also treated it as opposite over hypotenuse, where opposite from the theta, opposite from the angle, was a 4. So either way, whether you treat it as the opposite or you treat it as the y value, either way it was a 4 for my y value. All right, good question. Anything else? You guys online, how are we doing? All right, all right. Oh, thanks, Justin. Thanks, AD. Thanks, Audrey, Kislov. All right, all right. Thanks, Nicole. Okay, so we're doing all right. Let's makes me think we're good to move on then. Let's look at number 5. Evaluate the sine and cotangent functions at the quadrant angle 3 pi halves. So quadrant angle, as in 3 pi halves. Look at this. 3 pi halves is right on my y-axis. So it's like right there we go. It's like a negative y value down there. They want the sine and cotangent functions at that. I'm going to use the unit circle for this. On my unit circle, does anybody actually remember what this xy point was down at 3 pi halves? What do we got here? Ooh, 0, -1. Nice, Justin. What made you think that was, or what like helped you remember that? 0, -1. That's true. How'd you know that? Nice, Nicole. 0, -1. Did you just like straight up memorize it, or was there kind of like a hint? Just know it's at the bottom. Okay, at the bottom. In fact, the reason we call it a unit circle is it's got a radius of 1 unit. So like this distance here had to be a distance of 1, which would make you be at the point 0, -1. So that is totally true. We got the point 0, -1. So my sine was the y over r, right? Do I really need the radius on the unit circle though? I don't think I need the radius on my unit circle. Like my radius is a 1. Do I really need to divide by 1? Not so much. So I'm going to do my sine of 3 pi halves by just taking just the y value, -1. You can put -1 over 1, but I'm going to do the simplified answer, -1. Cotangents. Cotangent of 3 pi halves. All right. So my cotangent, looking up here, cotangent is the x over the y. And your y can't be 0. We don't want to divide by 0. So I'm going to take my x, which is 0 over the y, which is -1. I can divide by -1. That's fine. This will simplify down to just plain 0. Okay, so this was on my y-axis. Do you guys have any questions about if you get a point on any x-axis, y-axis, any of these with a 0? Any questions?
So the sine,
Mhm.
you got -1,
Uh-huh.
and that's just, okay, no, because it's the,
So the sign, what we looked at on our notes, the sign was the y over r. So it's like -1 over 1. I didn't really need to divide by 1 though. Whenever I have points on my actual unit circle, then I wasn't too worried about the radius there because I didn't need to divide by r. But if this was some other point, maybe I had the point, maybe it got me down here at like 0, -3 or something. Sure. Then I would have to do my y value over the r, which would be 3 in that case. I'd have to do like -3 over 3, if that makes any sense.
Yeah.
Okay. All right. Anything else? Now I've got one last type of problems we're going to look at. These are for the reference angle here. So your reference angle, there we go. It says let theta be an angle in standard position, which standard position means that you are starting on the positive x-axis and rotating counterclockwise. So let theta be an angle in standard position. Its reference angle is the acute angle. What does acute mean again? Does anybody know what an acute angle is? Less than 90. Okay, specifically between 0 and 90 degrees. If we're talking radians, that would be between 0 radians and pi halves radians. Okay, so that would be an acute angle, and they're calling it theta prime. So its reference angle is the acute angle if theta prime formed by the terminal side of theta and the horizontal axis, the x-axis. Okay. So notice that if you went more than the first quadrant, so this is more than 90 degrees, right? They're going to call their reference angle this part right here. That is now between 0 and 90. That's between 0 and pi halves. Okay, so if you even went past your 180 degrees, I'm just going to get this little reference angle to the x-axis. It was not going to the y-axis. Let's clarify here. It should go to the horizontal to the x-axis. I see this every year. I see people calling this the reference angle. That is not true. We need it to go to the x-axis. Even if it goes, all the way past, your negative y-axis, this right here is going to be my theta prime. That is my reference angle. Should be between 0 and 90. 0 and 90 to the x-axis. All right, so let's find the reference angle of like 300 degrees. So like, Shira, which quadrant is 300 degrees in?
Quadrant 4.
Totally, quadrant 4. Nice. So it went past the 90, it went past the 180, went past the 270, so it's over here in quadrant 4. It's my 300 degrees. But I need the reference angle. So I need it to be this angle that goes to the x-axis. Here's my x-axis. Let's see, I know that 360 is a full circle, right? So if I'm going to finish off my full circle, this would have to be 60 degrees for my reference angle. Okay, any questions before I move on? Okay, I'm going to pretty much do the same thing. It's just in radians now. All right, so Adam, where would my 14/9, wasn't there a pi on here?
No, there's no problem.
There's no. Did you guys see it on, did I not type it in or something? I'm going to put a pi there.
It looks like you should have a pi.
Yeah, I don't know why, but anyway, I'm going to put a pi there. Let's treat it like 14 pi over 9. Okay, so which quadrant will you put 14 pi over 9?
I'm thinking a wild guess is 3. Yeah.
With a wild guess?
Yeah.
Is that your wild guess as well?
No.
3? Quadrant 3, let's see. I know that in terms of ninths, this is pi halves up at the top there. In terms of ninths, maybe I'll put it as like a 4.5 pi over 9. Does that make any sense? Same thing as pi halves. Okay, and then this is usually we treat it as just plain pi, which would be like 9 pi ninths. It's like a 1 pi, right? All right, usually this is 3 pi halves. Okay. You got it right? So let's see, this would be 3 pi halves if I'm looking in terms of ninths, right? That would be, let's see, 13.5 pi ninths.
Yeah.
Oh, so you got close. Which quadrant am I in?
4.
Fourth quadrant. Okay, because 13.5, I'm going with 14 pi ninths. So I'm going to go a little past my 13.5. But I don't even care how far past it. I'm in the fourth quadrant. All right, so then let's find this reference angle that goes to the x-axis. I'm going to find it in radians. They gave me the original angle in radians, so I'm going to find my reference angle. And I do know that 2 pi is a full circle. So what I did over here was I took 360. I did 360 minus 300, and I got 60. I took like a full circle minus what they gave me. I'm going to do in this one full circle, but just in radians. I'm going to do 2 pi minus my 14 pi over 9. So I'll treat to the number 2, I'll treat it like 18 halves, or sorry, 18 ninths, excuse me, instead of a 2 pi. So 18 minus 14, that gives me 4 pi ninths. So 4 pi ninths is my, they're going to call it theta prime. This is my reference angle. All right, I got one more. Any questions on this before I move on to the last one for today?
Yeah, are those 3.13.5 and 4.5 or 4 times 5 pi or 13 times 5 pi?
It's 13.5. This is a 4.5, because like, isn't 4.5 half of 9?
Oh, I see.
That's why I was doing like my pi halves as 4.5 pi over 9. I was trying to compare it to my, yeah, no problem. All right, so let's do this one more time with a negative angle. Ooh, negative 135 degrees. All right, so Jackson, where does my negative 135 degrees end up? Like which quadrant? Quadrant 3, okay. So yeah, negative 135, so like here's negative 90. This would be negative 180, but isn't 135 between 90 and 80? So like, yeah, you're right. It would end up in this quadrant 3. Nice. So we're gonna find this reference angle that goes to the x-axis. All right, I know that half a circle, like if I finish this off, half a circle is 180 degrees. Let's do, okay. I should have a positive angle. This said I was supposed to have something between 0 and 90, not negative 90, between 0 and a positive 90. Or if I'm in radians, 0 and a positive pi halves. So I want this to be some positive angle. And if I already went 135 degrees, let's figure out how much I have left to get to the 180. I'm going to do a 180 minus 135. All right, so Jackson, how much do I have left? $65. Oh, yeah, there you go. 45. Nice. So I have 45 degrees, a positive 45 degrees for this reference angle, the theta prime. Okay. All right, so this is where we're going to end today.